Hello students. In last session we explained continuity of function. That means how to say whether the function is continuous or not at a point. So in this session we are discussing some more examples to check whether the given function f of x is continuous or discontinuous. And I already explained the given function f of x is continuous only when its left hand limit, right hand limit and value of the function f of x. If these three are equal, then we can say that f of x is continuous at a given point. Otherwise it is discontinuous. Okay. Let's see one of the example. F of x is x plus 2 when x is less than or equal to 1 and f of x equal to x minus 2 if x greater than 1. So here f of x is divided into 2 on the basis of this interval. So first interval is x less than or equal to 1 means all the values of less than 1 and equal to 1 f of x is defined as x plus 2 and more than 1 all the values of x more than 1 f of x is defined as x minus 2. Let's see this f of x is continuous or not at a point and we want to determine what is the point. Look at this interval. What is the common number here? This is an easy method. What is the common number here? 1. So we have to check at a point x equal to 1 whether the function is continuous or not. So we want to see left hand limit, right hand limit and value of the function. So we are going to find firstly what is its left hand limit. So left hand limit is limit x tends to, write the point here 1. Now write a negative sign on the top of 1. So this represents left hand limit. It is not negative 1. It represents only left hand limit of the function f of x. Now in the next step we want to rewrite f of x from this interval. So 1 minus means it is less than 1. So less than 1 belongs to this interval and in this interval f of x is defined as x plus 2. So replace here f of x as x plus 2. Now apply the limit. Apply the limit means put the value x equal to 1 here. So don't minus 1. It is only a negative, left hand limit representation. Okay. So put x equal to 1 here so that left hand limit becomes 3. Now what is right hand limit? That is limit x tends to 1 plus. So 1 plus is represent right hand limit of the function f of x. Now again replace f of x. So 1 plus means more than 1. So more than 1 belongs to this interval and in this interval f of x is defined as x minus 2. So we replace f of x. Now in the next step apply the limit. Apply the limit means put x equal to 1 so that right hand limit becomes 1 minus 2 equal to minus 1. So look at here, left hand limit is 3, right hand limit is minus 1. Are they equal? No. Left hand limit not equal to right hand limit. And therefore we can say that f is not continuous at a point x equal to 1 or f is discontinuous at a point x equal to 1. So if left hand limit and right hand limit are not equal, then no need to find value of f of x. If they are equal, we can see what is the value of f of x. Then only we can say whether the function is continuous or not. Okay. So left hand limit, right hand limit. Look at the symbol. Left hand limit is 1 minus. It is not negative 1. Only a representation of left hand limit. 1 plus means right hand limit. And from here we want to replace f of x using this interval. 1 minus means less than 1. That is the interval. 1 plus means more than 1. This is the interval. So according to the interval, we have to replace the functions and then apply the limit. We can see left hand limit value and right hand limit value. Okay. Listen, we can find left hand limit and right hand limit in another method, another way also. Let's see left hand limit. The same question, we are going to find left hand limit in another way. Limit, actually it is limit x tends to 1 minus f of x. So here we can rewrite as, listen please, limit h tends to 0. Okay, limit h tends to 0, f of, look at this number and it is left hand limit, so you have to write f of 1 minus h. At the same time, right hand limit. Actually, right hand limit is limit x tends to 1 plus f of x. So it can be converted as limit h tends to 0. Okay, h tends to 0, f of, we want to see right hand limit 1 plus. So you have to write here 1 plus h. Left hand limit means 1 minus. So write here f of 1 minus h. Right hand limit means 1 plus. So then you have to write here f of 1 plus h. Now we are going to replacing here. 1 minus h means it is less than 1. So look at here. Less than 1 means this is the function x plus 2. So in the function x plus 2, look at here. We want to replace this x as 1 minus h. Okay, 1 minus h plus 2. So limit h tends to 0, 1 minus h plus 2. Now apply the limit here. H tends to 0. H tends to 0 means put h equal to 0 here. So what is the answer? 1 minus 0 plus 2. 1 minus 0 plus 2 is 1 plus 2, that is 3. Look at here. Here also left hand limit equal to 3. Now see right hand limit. So x tends to 1 plus f of x, rewritten as h tends to 0 f of 1 plus h. Now we are going to replace this f of 1 plus h. This limit h tends to 0. Look at here. F of 1 plus h means more than 1. More than 1 means this is the interval. In the interval, f of x is defined as x minus 2. Okay, x minus 2. So in this function x minus 2, we have to replace this x by 1 plus h. So it is 1 plus h minus 2. Is clear? Now apply the limit. Apply the limit means put h equal to 0. So what is the value? 1 plus 0 minus 2. So answer is minus 1. Look at here. Right hand limit equal to minus 1. So in the both ways we can find left hand limit and right hand limit. So in the notes I explain both the methods. It's up to you. You can accept one of the method. If you feel what is the easy method, you can follow it. Okay. Let's see another example. F of x equal to x plus 2 when x less than 1. F of x equal to 0 when x equal to 1. F of x equal to x minus 2 if x greater than 1. So 3 intervals are given. One is less than 1, greater than 1 and exactly equal to 1. So here the common number is 1. So we have to verify or check whether the function is continuous or discontinuous at a point x equal to 1. That's our aim. So we want to find left hand limit, right hand limit and value of the function. First we have to see left hand limit. So definition, left hand limit equal to limit x tends to, what is the common number? 1. So left hand limit, so represent, write a negative number here. Read as limit x tends to 1 minus f of x. Now next step is replace f of x. Look into the function, and 1 minus means less than 1. So this is the interval. So in this interval f of x is defined as x plus 2. So replace f of x as x plus 2. Now apply the limit. Apply the limit means don't put x equal to minus 1. It is not minus 1. It's only a representation. Put x equal to 1 here. So 1 plus 2 equal to 3. Left hand limit. Now right hand limit. Right hand limit equal to limit x tends to 1 plus, okay, more than 1. F of x equal to limit x tends to 1 plus. 1 plus means more than 1, greater than 1. So look at here, greater than 1 means this is the interval. In this interval f of x is defined as x minus 2. So here replace f of x as x minus 2 and then apply the limit. Apply the limit means put x equal to 1 here. 1 minus 2. 1 minus 2 equal to minus 1. So here left hand limit is not equal to right hand limit, and therefore the given function is not continuous. Okay. Or given function f is discontinuous at a point x equal to 1. Okay, is clear? We see left hand limit and right hand limit. So you have to note down how to find left hand limit and right hand limit. 1 minus means less than 1. So rewrite the function and apply the limit. 1 plus means more than 1. So replace the function and apply the limit. You can see both the limits are not equal to each other, and therefore f is discontinuous at a point x equal to 1. You can find left hand limit and right hand limit in another method also. You verify that whether left hand limit not equal to right hand limit or not. Okay.